Hello, I wanted to take a few minutes and talk about some algebra review and trigonometry review. I'm probably going to split this into several videos. So if we start at factoring, and we have several different methods here that you can use for factoring. The first one is the greatest common factor. That's what this GCF is greatest common factor. So what I'm looking for is the commonality between all of the terms that I see. So what I notice here is that all three of these terms is divisible by 3. And so I'm going to write a 3 out front. I also notice that all of them have an A in them, just one. Okay, I'm going to write a 3A. And then finally, I notice that all of them have at least one B, but some of them have more than one B. And so I'm going to write a B here. All right. What I'm going to do is I'm factored that out, and so I'm going to pretend like I'm kind of undistributing. And so what's left if I factor it out from this term right here, from the 3ab squared, is just a b, minus here the 15, the negative 15, or minus 15, divided by 3 is going to be a 5, and both the a and the b have been factored out, so I don't have that. That's a really ugly 5. Let me try it again. There we go. Plus, and in the last one, my constant, I've got a 6 divided by 3. That leaves me a 2. And then the a is all factored out, but the b, I have a b squared left. And so this is what I have here as far as the answer in the factored form. The next one I have here is to factor by grouping. And what I'm doing there is I'm looking at these two parts of, making a straight line, the two parts of this. What I notice is that these two, they look a lot alike. They both have an x squared term. So that's what I'm going to factor out. So I'm kind of doing the greatest common factor of just those two. So I have an x squared times an x plus a 4. And let me put it, well, let's wait. Over here, if I look at these two, what I notice is they both, I'm not crazy about carrying around negative signs, so I'm going to factor out a negative 3, so it'll be a minus a 3, times an x, now plus a 4 also, because the signs would change on that second term there, right? All right, so now what you notice is that I have an x plus 4 right here in this term and an x plus 4 right here in this term. So I've got two x plus 4s. So I'm going to factor those out now. So again, I'm factoring out the common term. So I have an x plus 4. And then what I'm going to do is that what's left, let's do a dark green, this right here, the x squared and the minus the 3, those are going to go together, and I'm going to have an x squared minus a 3. Now, if you're not sure if you did this right, you can always check. So if I do a real quick check here, we can just FOIL this out. I have an x plus a 4 times an x squared minus a 3. If I do firsts, I get an x squared, outers minus a 3x, inners plus a 4x squared, and lasts, I get a minus a 12. And you notice that these match up with what our original was. The 3x is ahead of the 4x squared, but it doesn't matter whether I'm doing, 2 plus 3 or 3 plus 2, it all comes out the same there. Okay? All right, so our check was good, and that means we did it correctly. And any of these factors we could redistribute, and what we'll see is we'll end up with the original again. Nice way to check your work. All right, trinomials. Remember, trinomials come in the form of ax squared plus bx plus c. And so what I'm looking for here is how do I factor this? When a equals 1, I'm just going to look at this last term right here. I want two values that multiply to this. So I'm looking for factors of 32 that when I multiply together, they equal 32. And then I want them to add up to this. So I know in this case that I'm going to have negative numbers there. Okay. So let's take a look at factors of 32. I get 1 times 32. Definitely cannot add those together in any way, shape, or form and come up with a 12. My next one is going to be how about a 2 times a 16? Nope, I could get an 18 or a negative 18 off of that, but nothing else. Let's see, not divisible by 3, but if I go to, let's go to 4, I get a 4 times an 8. And when I put those together, they equal 12. I'd like them to equal negative 12, so I'm going to put a negative sign in front of the 4 and a negative sign in front of the 8. So I have a negative 4 times a negative 8, that equals positive 32. And then negative 4 plus negative 8 is negative 12. So I'm good there. I'm going to go ahead and write this out then. I have an x minus a 4 times an x minus an 8. And that right there is my answer. I didn't circle my last one, so let me circle it for you just so you can find it easy. There we are. All right, trinomials. So here, what I'm looking for is using the AC method, all right? And so what I get is, let's say I have, in this case, I have a not equal to 1, so this is my ax squared plus bx plus c, all right? That means that a times c is equal to 2 times my 12, and that's equal to 24. And so what I'm looking for is I'm looking for two numbers that multiply. So I want it to multiply to be 24, and I want it to add to be 11. Okay, so let's take a look at some factors of 24. Again, this is positive, so they're either both positive or both negative. Because that middle one is positive, it's always going to be positive. But 1 times 24, definitely not. If I added those together, I'd get a 25, so not that. How about 2 times 12? Nope, that's going to equal 14, so not that, but I'm getting closer. Let's go to 3 times 8. Hey, 3 plus 8 is equal to 11, and so I have a winner here. Now what I'm going to do is I'm going to take the 3 and the 8, and I'm going to use grouping now. So I'm going to say that this right here is equal to 2x squared plus an 8x plus a 3x plus a 12. Now you'll notice I put it in a different order, and the reason I did that is because I noticed the 2 and the 8 are both divisible by 2, and the 3 and the 12 are also, and so it felt like a good fit. If you see a different order, go for it and see what happens, all right? So now I'm going to actually let's do our grouping, factor by grouping, all right, same process. This is going to be equal to 2x times my x plus a 4, plus, in the second term, 3 is a common factor of both, so I have a positive plus 3 times an x plus a 4. Again, you notice that I have x plus 4 and x plus 4. And so I'm going to have an x plus 4 times what was left over here was this 2x plus 3. So I'm going to have a 2x plus 3. And that's going to be my factor. Again, if you want to FOIL that or distribute that and check it, you can. All right. My next one, difference of squares. So I'm actually going to use the one that's right below it for right now. I'm going to use a 49 minus a 16x squared, and I'm going to change the next one down to a plus sign down there by b. All right. So difference of squares is when I have an a squared minus a b squared, then I know that's equal to a plus b times the quantity a minus b. So what I'm going to do is I'm going to come over here. I'm going to say, well, a here is equal to the square root of 49, and that's going to be equal to 7. And my b here is equal to the square root of 16x squared. I square root both of those, remember. That becomes a 4x. So now subbing in, what I'm going to get is this is equal to a 7 plus a 4x times a 7 minus a 4x. Oh, it almost became a 5. 4x. There we are. And this is going to be my factors here. All right. See the a plus the b and the a minus the b. If you did it in the separate order, if you did a minus b times a plus b, that would also work for you. Now in b, sum of squares, that is going to be a prime. So that's the difference between this difference of squares from right up here and a sum of squares down here. So with my sum of squares, I would have something like an a squared plus a b squared, and that's prime. All right. So that means my 49 plus a 16x squared, that is going to be really zoomed in, and it's going to be prime. Okay, that's my answer right there. If we want to talk real quick about cubes, we have a difference of cubes and a sum of cubes, and kind of a cool thing to watch with this one. If I'm looking at my difference and sum of cubes, I key off of this symbol right here, the minus and the difference of cubes and the plus. And what I notice is that both of them have the same pattern, an a minus b times an a squared plus ab plus a b squared. And the second one says a plus a b times an a squared minus an ab plus a b squared. So it's really just the signs, but not the order of the a and the b that are changing. So what I notice is that, let's pick this one. This sign is the same in both of them. Notice that my a plus b or a minus b, it's the same sign. This sign right here is the opposite of what I started out with. Same here, opposite. And my last one is always positive. It's always a plus. So kind of a nice way to remember it. If I have a difference or sum of cubes, I have the same sign, the opposite sign, and always positive. So let's talk about what our cubes look like for the a and the b. So my a here is going to be the cube root this time of x cubed, and that's x. And my b is going to be the cube root of 64. And if you know this, that's great. If not, you can use a calculator. That's going to be equal to 4. So what I'm going to get here is that this is equal to, remember, I'm going to keep the signs the same in the middle of this one, an x minus a 4 times an x squared, that's my a squared, plus my a times b, that's a 4x, plus, always positive on the last one, a b squared, that's a 16. And that'll give me my factored difference of cubes. For the sum of cubes down here, I'm using the same x squared, this time plus 64. So I'm going to do the same idea. I'm going to have an x, this time plus, because it's the same, 4 times an x squared, that's my a squared, the different sign, the opposite sign of what I have right here. So minus an a times a b, so a 4x, and then always positive, plus a b squared, that's going to be a 16. So this is my answer here. Not too bad, right? Let's take a look real quick at the perfect square trinomials, and then we'll finish this video and I'll start solving quadratics. Here I know that a plus b squared, that whole quantity squared, is a squared plus 2ab plus b squared. And if I have an a minus b squared, the whole thing squared, then I get an a squared, and the only difference is I get this minus 2ab plus the b squared, all right? So here what I'm going to do is I'm suspecting, based on the fact that when I look at this, I have this 9x squared. That's 9 is a perfect square, x squared is a perfect square. And the 49y squared, again, both 49 is 7 squared and y squared, y squared. That was redundant. Then I could say that a is equal to the square root of 9x squared. Make sure you square root both. That's a 3x. And b here is going to be the square root of my 49y squared, and that's a 7y. Now the reason I keyed off of that is because I want to check this middle term here and see whether or not this term, oh, that's not what I wanted to do, whether or not this term right here is equal to 2 times AB. Okay, so I'm looking at this term right here. So if I do 2 times 3x times 7y, what I get is 2 times 3 is 6, and 6 times 7 is a 42. So I get a 42xy. So that matches right there. The minus sign's already there. And so what I know then is that I have an a 3x minus my b, 7y, and it's all squared. Right? So that's my factors for that. And that takes care of the factoring portion of this. And I'm going to go ahead and pick up on solving quadratics and moving down on other algebra things that we should know in the next video. So I'll see you soon.